the text and access to the videos?
Yeah. Yeah, I think so.
Okay, good. I'll just start by saying, again, this is a high-level program. We're not getting into too much detail. It's fairly quick, but it's meant to describe the process that we work through, give you awareness of the relevant codes that apply, what to consider, where to look, and obviously every job is different. So it's not a recipe for, you need to look at these codes for each job as they apply. Okay. So today we're talking about fire safety and fire matrix. So I'll share my screen. So I'll bring those notes up. So can you see the notes?
Yes.
All good. Okay, thank you. So the NCC, National Construction Code, used to be called the BSA, which was the Building Code of Australia. It classifies buildings according to their usage. For example, an office building is class 5 and a shopping centre is class 6. Now, I think most of you would have seen this, but just in case, this is the BCA. So part A6 of the BCA gives you building classification. I think all the people from MEPEC are familiar with this. Are you guys from Mott MacDonald aware of this, building classifications?
Yeah, but I've seen it before.
We can quickly go to that. So building classification is class 1, which is basically a house. So it's really from buildings classes 2 to 9 that we deal with. 2, 3 and 4 are residential. 5 is an office. 6 is basically shops. 7 could be car park or storage building, and so on. And class 9 is public buildings. Class 9A is a hospital, healthcare building. And 9B is an assembly building. Class 10, again, that doesn't really apply to the work that we do. So let's go back to the index again. And back to the notes. Based on the building classification, the NCC specifies regulations in relation to fire safety, ventilation, energy efficiency, etc. The NCC refers to Australian standards where applicable, such as A1668 Part 1 and 2. Now, I think most of you should know by now, or you need to be aware that the NCC and AS1668 Part 1 and 2 are probably the most important things that you need to be familiar with. And you need to be looking at those a lot when you start a new project or during the course of a project. You need to refer to those and make sure that you are clear on what the requirements are. So in some cases, the NCC will require the HVAC systems to provide smoke hazard management, which may involve features such as system shutdown, stair pressurisation, smoke exhaust, etc. And to see, I've added a couple of notes on here which aren't on your notes. In the highlighted notes I've put here to give you the references, so we can have a look at those references. If we go to Part E2 of the BCA, so Section E refers to services and equipment. Part E2 is smoke hazard management. So we'll go in there. The first bit is the preamble of the basic background to it. We come down to Table E 2.2a. Now, this is a really important table. It says, first part says, a fire isolated stairway, say the stair in a multi-level building, for instance, or a fire isolated passageway serving any story above an effective height of 25 metres. Now, do we know what an effective height actually means? Well, I'll just give you a quick explanation. The effective height of a building is the height from where you would exit the building, the egress point. So let's just make it simple. If you've got a multi-storey building and you've got an exit at ground level out into the street, that's your starting point. That's the bottom of the building in terms of this effective height. The top level is the floor level of the highest occupied floor. So if the building is 15 stories high, then it's the top height is the floor of the 15th floor. Does that make sense? So then you can get that distance from the RLs on the architectural drawing and determine what the effective height is. But excuse me, 25 metres is important because if a building is over 25 metres high, and as you go down the table, here we are, buildings more than 25 metres in effective height, it brings in a lot of extra requirements for smoke hazard management. So you can read through, for instance, a class 5, 6, 7B, 8 or 9B must be provided with a zone pressurisation system if it's more than 25 metres in effective height. Okay, to get the details, to find out what the details of a zone pressurisation system are, you need to go to AS 1668 Part 1. And there's a whole section in that code that talks about zone pressurisation systems. And so on. I'm not going to go through this now because we'll be here all day, but then you can come down to buildings not more than 25 metres in effective height. And if you have a look through that, you can see that there's no requirements for stair pressurisation and things like that, generally speaking, and smoke exhaust. So that's an important one to get your head around. You may be working on projects at the moment that this doesn't apply to, but that's, it's worth just having a look through it. And don't expect that you're going to memorise it. You just have to go back and refer to it when you need to. While we're talking about, we'll go back to the notes. So the fire mode refers to functions of the HVAC systems during a fire alarm event in the building. I'll just show you. This is the contents page of AS 1668 Part 1. So there's a lot of information in this code, and once again, don't expect to memorise it, but just be familiar with what's in it and always refer to it or know when to refer to it. So basically all of this code you need to be familiar with. When you come to something like a zone pressurisation system that we're just talking about, there's a chapter there on those particular systems. Section 9 is hot layer smoke control systems. This really applies to shopping centres. So when you're looking at the NCC, you're dealing with a shopping centre. Depending on the size of the shopping centre, it's not going to apply to a small shop, obviously, but if you've got like a Woolies store or a large shopping centre that's generally over 2,000 square metres, then these things come into play. And hot layer smoke control systems is where you have smoke exhaust at the high level. You might have seen them. You see the grills in a Woolies shopping centre or in the mall of a large shopping centre. That's generally smoke exhaust, okay? Protection of fire isolated exits. We're talking there about stair pressurisation. Air purge systems. It's another form of smoke exhaust and so on. So there's all those sections there that you need to refer to when appropriate. And buildings may have one or several fire zones or fire compartments. each fire compartment is fire isolated by its construction from all other fire compartments. And I've added a note there may also be several smoke zones in a building, and the smoke zone will be protected by a smoke wall, which is not a firewall, but it's a smoke barrier, so the smoke can't get from one compartment to the other, and in which case you'd need smoke dampers in those walls. A Class 9A building, for instance, which is a hospital or covers hospitals, hospitals will generally have lots of fire zones and lots of smoke zones, because they a smoke zone is 500 square metres. A fire zone is 1,000 square metres. So if you've got an area that's 1,000 square metres and it's a fire zone, and depending on if it's a patient area, it might be an administration area, which is different again. But if it's a patient area, it's normally broken up into smoke zones of 500 square metres maximum, which is based on the ability to get people out of the building in the event of a fire. Okay, so these codes are all written around fire safety, and the first important point is protection of people, and then obviously protection of property and other things. But it's getting people out of the building safely if there's a fire alarm. So they're the important things to remember. What are we trying to achieve? We want to get people out of the building if there's a fire alarm. So what else have we got to go through there? All right, so for projects which have some level of fire mode, we produce a fire matrix. Now, the guys from Mott MacDonald, I don't know whether you've been involved in these, but I know that the MEPAC team have. The fire matrix is basically a cause and effect schedule, and I'll show you one in a second. It sets out the function that each fan, air handling unit, motorised damper, etc., which has a function in fire mode, is required to perform when a fire alarm is activated. Excuse me, I need a drink. So here's a typical fire matrix. Now, Ananda might recall this one because this was a job that you worked on, and that's I've taken off the name of the project for protection of the innocent. But this is an example of, this is quite a large fire matrix. And when I talk about process, we've been through the process of, well, not all you guys have been present, but working through all the equipment schedules, and then the electrical schedules, and then the controls systems, and now we come to looking at fire. So these over here, can you all see that spreadsheet okay? Just give me a nod or a thumbs up or something. This is broken down into switchboards. So there's a main switchboard or mechanical switchboard, MSSB1, and each floor has got a separate board for controlling dampers. On MSSB1, there's some stair pressurization fans. Now this building, if I just scroll across, it's got 15 levels. So it's more than 25 metres high. So it brings in all those, and it's an office building, brings in all those requirements in NCC Table E22A that I mentioned before. Okay. And so all these levels are different fire zones. And you can see the bit of a pattern that forms in this part of the matrix. So we'll start at the top. So we've got F1, which is stair pressurization. It has a supply air smoke detector, which is a requirement of the code. So that if there's smoke in the stair pressurization supply, the fan would stop and it would automatically restart. Once the smoke clears, it'll start again. So when there's a fire alarm, the stair pressurisation fans, F1 and F2, start straight away. So over here, general fire alarm, it runs. I'll just highlight that so you can see it a bit better. Where there's a fire alarm anywhere in the building, the stair pressurisation runs. Okay. The next line, there's stair pressurisation damper, which will be, I'm not sure whether that's a pressure control damper. Well, it will be anyway, but what its actual function is in this case, but there's a damper associated with that fan, and that damper is open. So if there's no fire alarm over here, normal operation, it's closed, and the stair pressurisation fan is not running. So that's pretty clear what's going on there. So if we go down to level 15, for instance, just have a look at these three lines. There's the smoke relief on this job is floor by floor. Sometimes you have a central smoke exhaust system at the top of the building. The smoke goes up and gets exhausted out. In this case, it's on each floor. So for level 15, there's a relief damper on the north, a relief damper on the south, and a lift lobby damper, which are all required to operate in some way in the fire mode. In this case, we'll go to level 15, and they're open. But you see the dampers on the other floors are all closed. They're not affected by this. So it's a matter of going through each floor and working out what's got to happen and fill in the relevant spaces. Fairly detailed, but you can see it follows a pattern. Once you get going and you understand how the system works, you can construct the matrix. Okay, we'll go back to now. Well, any questions? If you've got any questions, you can ask me as we go through rather than while it's fresh. No? Okay. Often a fire engineering report is produced for a project. Now, I know that, again, the MEPEC team have all seen these. Don't know whether you guys have been involved with working with fire engineers from Mott MacDonald, but just about every significant project now will have a fire engineering report, which is produced by a fire engineer. Quite often, they will come up with strategies which are a little bit different to what it says in the NCC or AS 1668. And again, their analysis is based on safety of occupants of the building. So they might come up with different ideas that satisfy the intent of the NCC, but may not be deemed to satisfy in that respect. So if you're using the NCC, the DTS, or deemed to satisfy, is basically doing everything that's written in the NCC. But if the fire engineer might do something different but still satisfies the objectives of the NCC. Does that make sense? So there are different ways of going about it. So if there is a fire engineering report, that's a very important document that has to be complied with for the project. And so as mechanical services engineers, our designs and construction also have to comply with the fire engineering report, which may be different to the way we would have done it if we were going to do a deemed to satisfy. So you always have to read that. Make sure that you understand what the FER is asking for, and comply with those requirements, and incorporate those requirements in the fire matrix. So I've got an FER, I think, somewhere. Again, this is one I've just taken out of their file, so I'm not, don't want to highlight anything in particular. It's just, it's a very big document. You can see there's 174 pages there. Now, in that document, for the mechanical services, it might be only one page. but you just have to have a look through it, and there'll be an index proposed fire safety strategy. So you can see fire and smoke separation, protection of openings, egress provisions, fire hydrants, hose reels, sprinklers. It's a bit like rewriting the NCC, if you like, in an abbreviated form. Smoke detection alarm, emergency warning and intercom, smoke hazard management. So when you get to that one, that's what's going to affect the mechanical services. So if we go to that, and if we click on that, I'll go to page 21. What page is it? Showing? Sorry, page 21. Smoke hazard management. Okay. The building shall be provided with a stair pressurisation system and zone smoke control system in accordance with NCC DTS. Okay, so that's it. So in this case, they're not doing anything different. I didn't actually look at this before, to be honest. I just opened this up so I could show you an FER. Again, it's just sort of getting into your mind that these are things that you need to be aware of and you need to refer to. Don't forget that there might be an FER on the project and you need to refer to it. So in this case, they're just saying the designer has the responsibility to design the smoke hazard management in accordance with the NCC deemed to satisfy requirements. So you go back to the NCC and AS 1668 Part 1 and design the system, and the FER has no changes to that. I've seen all sorts of projects where the FER calls for different things. So for instance, there might be a project that is more than 25 metres high, and don't quote me on this, but they might say, look, on this particular project, because we've got all these other safety features such as sprinklers, smoke alarms, early detection system, VESDA systems, lots of safeties. They might say, in this particular project, we've done the modelling and we don't think it's necessary to have a smoke hazard management system. Bang, done. Saves a lot of money. Smoke hazard management systems are very expensive. So if they can be written out of a project, it's going to reduce the cost of the mechanical services system, as long as it's not affecting the safety. And that's where the fire engineer takes that responsibility to say it's not required. Happy days. But also there might be a project that's less than 25 metres high. It might be a school or something where there's a lot of people, a hospital, and again, their safety is paramount. So they might say this building's only 2 stories high, but we believe that stair pressurisation is required for whatever reason. And if they put that in their fire engineering report, that's part of the documentation for the project, and we have to do that. Okay. So
can I ask something?
Yep.
So if we have an FER and something is required, while it's only an option in the NCC, we go for it as a requirement, as a mandatory requirement. What if it is the opposite? What if it's a requirement in the NCC, but the fire engineer decided to have it as an option?
Okay, so generally there won't be any options. It'll be one or the other. So either the fire engineer will say, this is what has to be done on this project, whatever it may be, or he'll say what was shown on that document before, that you need to refer to the NCC, deemed to satisfy.
Yeah.
So it'll be one or the other. There won't be any ifs or buts, because someone's got to take responsibility for the specification of the project. In the absence of an FER, in other words, if there's no FER for a project, then we must go with the NCC. DTS, deemed to satisfy. So what it says in the NCC is what needs to be done. Having said that, there is a mechanism, and I didn't want to go into this in any detail, but just to let you know, if you think there's a better way it can be done, or there's a different way it can be done, you can go through a process of making an appeal to the, which is what the fire engineer basically does. He appeals to the building surveyor with an alternative approach, and the building surveyor would have to goes through that and approves it in essence for the project. So you can put up an application to the building surveyor and say we want to do it a different way, but then you'd have to have all sorts of analysis to back that up to say why it's still providing adequate safety. That's a pretty complex process, and not something that we would normally do, but consulting engineers may go down that path if you can see a different way of doing things. But in the contracting field, we wouldn't normally not go that way. It'd either be deemed to satisfy or in accordance with the FER. Okay. Anything else? Has that been clear enough? I think we've covered about half an hour, and I think it's quite a good time. 30 minutes is probably enough. I mean, we could sit here for an hour and talk about other things, but everyone's got things to do. You're all busy, and also it's a lot to absorb, which you know, I think half an hour we can get through enough for you to absorb for today, and then we can talk some more next week. So if you haven't got any questions, yep.
I just had a question with the fire matrix. Looking at it, it looks like a really detailed Excel document. So what stage of the project would the fire matrix usually be done?
At what stage?
Yeah, in the design process. 30%, 50%, 80%.
Oh, okay. Well, it's probably something that you should be working on at 30%.
Mm-hmm.
Because once you know what equipment you've got in the project, obviously you know how high the building is and what the smoke hazard management system is going to be for the project. Once you know all the equipment and the dampers, you can start to put together a fire matrix. On the contracting side, the process normally is to schedule all the equipment, and at the same and then do the electrical schedule to go with that, so that the subcontract electrician can be issued with that, so he can start working on the project. And pretty much straight after that electrical schedule is prepared, we would be working on the fire matrix. There is a sheet that we used to use that I haven't got a copy of here that I could show you, but we used to call it the big sheet because it was enormous. And it was an electrical schedule which was expanded to include the fire matrix. So it had everything on it. And it was a fantastic document, but it was huge. It was probably too big for big projects. It was too big and cumbersome to really handle. But anyway, to answer your question, as early as you can in the process, the fire matrix should be developing.
Thanks.
Because it's got to go through an approval process. You know, you put something down, and it's sort of your understanding of how it should operate, but then that would have to go into, well, you'd have to discuss that probably with the fire engineer to make sure that, and it's got to be shared with other contractors, because the fire contractor needs to know how our systems are going to operate in the fire mode, because there's interaction, interfacing between mechanical and fire, mechanical and electrical and so on. The fire services subcontractor has to provide the FIP, the fire indicator panel, and that interfaces with the mechanical for the fire mode. So see, this has got FIP control. So these switches are on the FIP, or the fire fan control panel, which is generally supplied by the fire services contractor as well, and installed adjacent to the fire indicator panel. So any fans that operate in the fire mode have to have control switches at the FIP so that when the fire brigade arrive, they can turn things on or off, or, you know, they can, if they think it's better to have a fan turned off to enable them to fight the fire, then they'll do that. Or they might say, it's not running, there's a problem, work that out, get it turned on again, because there's indicator lights with these switches as well that show that the fan's running or it's off. So that's the other important part. Apart from protecting the occupants of the building, it's also enabling the fire brigade to access the building to fight the fire. So they've got access to, or through these switches, they have some level of control over the mechanical services. But it's for the safety of them, the fire brigade, to be able to access where the fire is. And also they're going to find out, as soon as they get the fire indicator panel, where the fire is and what's running and what's not. Then they can make their decisions about how they go about trying to put the fire out. There's a lot of coordination involved in producing this matrix, and it's a very important document. Any other questions? No more questions? Okay, all good there. What I'm going to do, mainly for the benefit of all of you, but for those who have been, well, I guess Dua's the only one who's been involved through this whole process at the moment, but I'm going to issue you with just a summary of all the subjects we've discussed up to date, just so you can see in summary form what the process is that we've discussed. So I'll send that out. I've got your email addresses. I'll just send you an email, just for information. And it's basically taking the headings out of the notes from the training program. Just these headings are summarising where we're up to. So what we've covered and where we're up to. So next week we're up to manufacture and installation. So for the contracting side, this is where we go on site and we start to install all the equipment. So we're just going to talk about that. And then after that, we go into commissioning. Once it's all installed, we can start testing and commissioning and so on. So as I said, it's all a process, and you can't really say that a project starts at 1 and finishes at 100. You know, you might have to go backwards a few times or jump a few paces forward, but it's trying to get some sort of system into the way we do things so that basically you can tick them off as you work through them and follow a logical process. But there will always be some sort of distraction on the way, which means you have to jump around. Okay. I think that'll do for today. Thanks for listening in.